Hello and welcome to the first video in a series on programming with Python and with R. So I recommend that you pick one language to follow along with and the other sort of absorb it, get a feel for it. But to avoid confusing yourself, just actively code in one of these two languages that I'm going to show you. So the learning objectives of this first video are to take data in a CSV or comma-separated value format and import that into Python and R. You'll also get introduced to data structures including Numpy arrays in Python as well as lists in Python, and then in R, data structures such as data frames and vectors. And I'll show you how to perform some basic arithmetic with the data that you import. Now, chances are you already have some data that you want to import and work with. And so if you find that this video is not sufficient for understanding how to do that, particularly if you're working in R, I have another playlist called Emergency R. And there are two different videos in there that cover importing data. So one of them is for if you have your data in a spreadsheet software like Excel and you want to get it into R. And the other one is if you have it in some other row column format like tab delimited or something like that. Maybe some specialized format that came off of some piece of software, how you would import that. So take a look at those if you find that you haven't learned everything you need to know from this video. So first I want you to pick a location on your computer that's convenient. It can even be your desktop, and make a new folder that you'll use for our project today. I'm just going to call it video 1. You can call it something else if you like. And so there's a data set that we're going to use. It's this Russian miscanthus data set, so I have put this link in the video description. And so I'll give you a minute to go there. All right, assuming you're there, pause it if you're not and go find it. We're gonna take this CSV file and let's go to raw, and it's just going to show me this text here, and what I'm going to do is right click on it and then save as. If you're in a browser other than Chrome, you might have a slightly different procedure for doing that, but you want it to get to the point where you're saving it as this .csv file. So I'm going to go into my folder that I just made, and that's where I'm going to save it. Or if it went into your downloads folder on your computer, then take it and move it into the folder that you just created. So let's take a look at this data set. So I'm going to double click on it, and on my computer that will open it in Excel by default. If you don't have Excel, feel free to use LibreOffice or open it in Google Sheets to look at it. Now, if your own data are very large, you might not be able to open it in Excel, in which case if you're familiar with Bash, you can use the less command to preview it, or you can take a look at my emergency R video on using read table for some tips on how to preview the first few lines of a file in R. So this is information on some plants that were collected by my boss back in 2012. He got to go to Russia for that. Those were different times, but anyway, and so we have an accession number for each plant, what species it was, the latitude and longitude and elevation where it were collected, and then some measurements that were taken on the plant. So the stem height in meters, stem diameter in, yeah, it's got to be millimeters, and then the number of stems per quarter of a meter squared. So that's what's in this data set. So let's start with Python, and we're going to open Thonny to take a look at this. All right, so if you followed the installation video, you should have installed Thonny, and you should have also installed a Python package called Numpy. So if you haven't done that, then go back and take a look at that video. So to use that Python package, Numpy, I'm going to write a command called import Numpy. And you'll see that because import is a special word in Python, it highlighted it in bold and purple. And you'll also see that what I have on this upper left is sort of a text editor. So I'm going to click the Save button, and it's going to let me navigate around. So then if I go back and find that folder where I saved my CSV file, that is where I want to save this as well. So let's call it data import.py. Right, so this is a plain text file. You could open it with Notepad, you could open it with any other text editor, but we're editing it here in Thonny because this will let us send it right to Python. Okay, and so I'm going to create a variable that I'm going to call my CSV. And what that is going to contain is the file name. So I'll type opening quotes and then Russian underscore miscanthus.csv and then closing quotes, and you'll see that that highlighting went away. It was there to help remind me that I needed closing quotes. Right, so that is the name of that file. Right, and you can see here the file that I just saved, that's our Python script. Right, and I'm going to save it again, and then if I run it, now that it's run, you'll see that I have these variables that were created. So you can see that the variable myCSV has the value, that's this text string, that's the name of the file. And we also see that Numpy is a variable here that's been loaded, and that's because I imported it. Alright, so to actually read that, so right now this is just a piece of text, it's not the file itself. In fact, I could have written some file that didn't exist and it wouldn't have complained at me. So I'm going to use a different command to actually read that file. So that command is called gen from txt. And because that command comes from Numpy, I have to call it like this, where I say numpy.gen from txt. And that is something called a function. So to use a function, this is true in Python and R as well, we're going to use parentheses. And then what we put in the parentheses are called arguments to the function. So the first argument here is the name of the file, which I've put into that variable. So I could have also put this text right in there, but I like having it up at the head right here because then if I want to use this same script to read another file, I just change this part up here and I don't have to start digging through the script to see what I need to change. Alright, and so we have a few other arguments that we need to give to this. And what I'm going to do is I'm going to look up the help page to help remind me what they are. I also have them in my notes, but you should be able to look up help pages. So for Python, a lot of times I can do a Google search and find the help page for something. So if and it's giving me here a recommendation because I've already searched for it today, but if I search for NumPy gen from txt, I get the official documentation for it. Right. So one thing I want to change is the delimiter, which says how are the different cells within a row in this file separated. And because this is a comma separated value, that delimiter is a comma. So I'm going to say delimiter equals, and then in quotes I'm going to put a comma. You can use single quotes or double quotes pretty interchangeably in Python. So I use double quotes up here, single quotes up here, it doesn't matter. Another one is I want to skip the header because I do have a header row at the beginning of this file and Numpy really won't import that header, so I want to ignore it. So I'll say skip header equals 1 to say that there's just one header line. And then the last one is one called use calls. So this says which columns do I want to import. And with Numpy, I'm only going to import columns that contain numbers. In a minute, I'll show you how to import text as well. So I only want to specify the columns that contain numbers. And you'll see that it says 0 is the first, and then 1 is the second, etc. So that's, we'll see that whenever we number things in Python, it's going to start from 0 rather than starting from 1. And so let's see, if this is column 0, this is column 1, then we want to import columns 2, 3, 4, 5, 6, 7. Right? So I'll say use calls, I guess with an S, and then I'm going to also put these numbers in parentheses. 2, 3, 4, 5, 6, 7. And remember, there also needs to be a closing parentheses for the whole function call. So you'll see that it's highlighted blue at the end here and blue at the beginning here to show that they match. And if I move my cursor in one, now these are highlighted blue to show that they match. The other thing that I'm going to do is, so this just reads it, but it doesn't put anywhere. So I also want to put this into a variable. So I'm going to call it my data. Not a very creative name, but it does the job for me. Right? So then if I save that and run it, I got an error. Oh, I did this before too. I misspelled delimiter. So it says unexpected keyword argument delimiter, and that means that this keyword is not anything that was in that this list that I was looking at, which usually is an indication I just spelled it wrong. Right, so I fixed that. I'm going to save it again, and you'll notice before it's saved it had a little asterisk here, and now that it's saved there's nothing to save, and it grayed out the save button, so that's a good indication of whether you need to save or not. So I'll run it again, and now I have my data, and it's something called an array, but I can't really get a good look at it like that. But what an array is, an array is, this is a sort of a specific thing to this Numpy package, but it can be, in this case it's two-dimensional data, but it can be one-dimensional or three-dimensional, and the important part is that it's all the same type of thing in there. In this case it's all numbers. So if I wanted to print it out, I could add that print command to my script, save it again and run it. And now it's not printing the whole thing, but it's printing the beginning and the end of it. So the first 3 rows and the last 3 rows. Now pause the video, and for a quick exercise here, download the file testdelim.txt from the same GitHub location that's listed in the description, and try importing it with Numpy. And so you'll see down here, here's the output that I'm expecting from that, and I've blocked out the command. So I might also want to extract those columns so that I can do things with the columns, and also so I can remind myself again of what they mean, because I skipped a header and now that information is gone from this object. And it's always good to leave yourself some clues about what's actually going on. Another thing, since I'm about to start a new section of code, I'm going to add something called a comment. So anytime you start a line with this hash symbol, or I would call it the pound sign because I'm old, that tells Python to just ignore that line, which means that you can write anything in that line you want to write, which is, you should write an explanation of what the heck you're doing. So I'll write that explanation there. And so how do I get that first column? I'm going to use square brackets to do something called indexing, to tell it exactly what I want to extract. And because this is two-dimensional, I'm going to put a comma, and so whatever I put before the comma would indicate rows, and whatever I put after the comma would indicate columns. And so the latitude is that first column, and as I mentioned, we start numbering from 0, so I'm going to put a 0 in there. And I want every row because I just want latitude for the whole thing. And in this particular case, that means I just need to put a colon in there and nothing else. We'll get into in another video more about how to use that colon, but just know right now that if you want to extract every row or every column, you need to put a colon right there. And just to test it out before I do every column, let's print that one out and see what it looks like. Right, so now I see latitude up here, and now, so again, it printed my data out, and then underneath it, it printed out the latitude array, which is now a one-dimensional array because I just got one column. So I can go and do the rest of that. Longitude was the second one. Elevation was the third one. And what did we have after that? We had stem height. We had stem diameter. And we had stem density. Right. And I'm also thinking, you know what, I don't need to print this every time, but maybe sometimes I'd want to print it again to remind myself of what it looks like. So I'm going to do what's called commenting out a line. So I still have this there if I want to run it later, but for now, because it starts with a comment character, Python will ignore it. So if I save that and run it, now I see that I have all of these variables. And each one is an array in the same order as the rows of that spreadsheet, and it contains the data from that column of the spreadsheet. Okay, so what I want you to do now is pause the video for a few minutes, and I want you to take this script and save it as something else. So we'll say data import exercise.py. And so I want you to modify it, and what I want you to do is go into Excel and just make a little tiny test spreadsheet with just a few rows and a few columns, and have it contain numerical data, and then save that as a CSV file, and then try importing it, modifying this script to do that import. Okay, welcome back. So let's go through that exercise. So I'm going to make a new spreadsheet. Right, and let's keep it simple. So we'll have a column A that's 3, 6.5, 7, just some random numbers. Maybe a column B that's 1, 2, 20.3. Really, you could put any numbers in here. And I'm going to save that, and let's do more save options. We'll save it into this folder again. All right, this folder where we are working. And instead of an Excel workbook, I'm going to save it as CSV, delimited. And let's call it test CSV. right? And so then I can double check that's there, right? And I have my original script and now this one that I'm going to modify. Right, so we'll call this test CSV, right? And like I said, I changed this here, now I don't have to worry about changing it down here. Right, and I only have 2 columns this time, and in fact I don't have any columns that I want to skip, so I can do it 2 ways. I can say I want columns 0 and 1, or I could just not specify and then it will take all of them. Right? And then, of course, I don't have this many columns anymore, so I'm going to say A equals my data 0, and B equals my data 1. And just to confirm that it worked, let's print the data out again, and we'll print out A and B. So I'll save that and then run it, and there I get my data is this much smaller array, and I get column A and column B. You'll notice for things where I had an integer, it puts a decimal point after it anyway, and that's just to show me that it's not storing it as an integer, it's storing it as a decimal, because there are some other decimals here. But I can see, okay, that here's the array printed out with my 2 columns and my 3 rows, and then here it printed the first column and then printed the second column. Okay, so let's go back to our original script that we were working with. Now, I promised that we would also import the 2 columns of text, so let's do that too. So I'm going to import another module called CSV, which you imagine that's for reading CSV files. And I didn't have to install this with pip because it comes installed with Python. Okay. And before I start reading the file, I'm actually going to set up the variables where I'm going to store the data. So we'll call it accession for those accession numbers in the first row, and species for the species names in the second column. Sorry, I meant first column for accession and second column for species. And what I'm going to do is I'm going to say equals, and then I'm just going to put square brackets, which makes an empty list. So because I'm using sort of vanilla Python for this, what I'm creating here is a list rather than a one-dimensional Numpy array, although in many ways they're going to behave similarly. And so I'll do the same for species, just create that as an empty list here. And then I'm going to make a command for reading the file. So here I'm going to say with open my CSV new line equals, and then just type 2 quotes next to each other with nothing in between them. Mode equals lowercase r in quotes. So for now, just know that this is like a special recipe for opening a CSV file. We'll get more into the nuts and bolts of it in another video. And I'm going to say as my con, and then a colon. And then I'll hit enter. And you'll notice it's automatically indented by 4 spaces here. So I'm going to create something called my reader. So kind of like I did numpy.genFromText to get that genFromText function. In the CSV module, I want a command called reader, so I'll use that. And I will pass it this connection object that I made up here. Basically, the with command is to make sure that I close that file when I'm done with it, which is kind of automatically handled down here, but it's not automatically handled in normal Python. All right. Again, I want to skip the header, but I can actually put that header information into an object or a variable. So I'll say next my reader, which will grab the first line. If I ran next again, it would grab the second line. And then for row in my reader, and then another colon, and it's going to indent it again, kind of like it did with width. Again, we're going to get more into the for command in another video, but just for now, think of it as this is a recipe for reading a CSV file. So we want to add the first element of that row to the accession list. So I'm going to say accession.append to add something to that list. And I'm going to grab the first thing from that row. And then species.append to add something to the species list. And I'm going to grab the second item from that row. So the row itself is kind of a one-dimensional thing. It's it's a list, but you can think of it kind of like these one-dimensional arrays. So this says grab the first element. This says grab the second element. All right, and then basically we're done with that. Maybe we want to print it out to look at it. Let's do that just as a test that it worked okay. So if I run that, now I see that species and accession showed up. In fact, I have row as the last row that it read as well, and it printed out my accessions. Now for a quick exercise, I'd like you to take this script and see if you can figure out what goes in this box right here that I grayed out. So this is actually a simpler example of a file that is not delimited by any particular character, where we want to read each entire line of the file as one item. So you can get this plain text example.txt from the GitHub website. Right, so I'm creating a list called my lines that I'm going to put each line of the file will be one item in that list. And similarly to before, I'm opening a connection to the file, but instead of looping through rows of a CSV, I'm just looping through the connection itself. So the line that you need to fill in is similar to something that we just did. Okay, and both lists and arrays can be indexed in a similar way. So I could put square brackets here. Let's say I just wanted to look at, the 15th item. I started typing 15 instead of 14. Right, so that'll get me the 15th item of each of those. So if I run that, now I get that printed out. What was the accession, the species, the latitude, and the longitude, just for that row. All right. I can also do some arithmetic with the arrays. So stem height, if you recall, that was in meters. Let's say I wanted it in centimeters. I could actually do a simple multiplication to make that conversion. And I told you I'd explain more about the colon later, but just trust me that this command will get you the first 20. I just want to do this to confirm that it got converted right. In fact, that's a great time for me to make a comment. Right? And so there's my 4 lines I printed before, and then the first 20 items of the stem height, and then I've checked that the first 20 items, when I multiplied it by 100, really do look like I multiplied it by 100. So yeah, as you can see, this asterisk is multiplication. We have addition. I'm just typing things straight in here because it's not worth making a script for it. You can do commands straight down here as well. You can do subtraction. You can do division like that. And if you want to raise something to a power, use 2 asterisks. All right. So take a few minutes and try converting the elevation from meters to feet. So pause the video and try that out. All right, welcome back. So let's see what that conversion is. Right, we have 3.28 feet in each meter. So I could say elevation feet equals elevation times 3.28. And maybe I want to similarly check those to confirm that they look right. All right, and that looks about right for the conversion. All right, so that covers the Python portion of this lesson, and now we'll move on to the R one, which will be a bit shorter, but we're going to show you how to do the same stuff. Okay, so if you've got RStudio installed, it should look something like this. There is a video explaining how and where to get R and RStudio, so that's 2 things you need to install. I'll link to that in the description. You should also, if you didn't at the beginning of this video, set up a folder for this project and download the dataset and put it in that folder. Go back to the beginning of the video and do that right now, and then come back to this part. So assuming you have that folder set up, what we're going to do is we're going to set it up as a project in RStudio, which is a collection of files that are all in one folder, and as implied, they're all related to one project that you're doing. So that's File and New Project. And sometimes that takes a moment to open. And since I made a folder, I'm going to do Existing Directory. And I will browse to that. So that was here, my Video 1 folder that I made. Create Project. We'll take a moment to set it up. And now I see that I have any files that were already in there, including Python files. You actually can edit Python files in R, you just can't. Well, I guess you can even run them from RStudio. So if you get fancy and like to use some of both, RStudio is not a bad program for doing that. But you should at least have this Russian miscanthus.csv in here. And you'll see that it also created this file called video1.rproj. If I click on that, I just have some options that I can set for the project. Okay, so a lot like we did in Thani, if I go here and make a new R script, I get this text editor in the upper left here. And down in the lower left, I have a console, which is pretty much just like that shell that we had in Thani. So the command that I'm going to use for importing a CSV file is read.csv. And this is going to do the work of both of the sections that I showed you before. So before we imported the numbers and the text separately, and it was kind of a lot of code, but this will do both at once. And so I'm going to put in the name of my file. In fact, let's do what I did before and say my CSV, and then assign that file name to it. Now, if you like, for simplicity, you can use the equals sign. But in R, there's another symbol you can use, which is an arrow that you make by making a less than sign followed by a minus sign with no space in between. And we call that the assignment operator. So it's a matter of personal preference, but sort of the standard is to use this arrow because the equals sign is used for some other things. And this way it's easy to tell them apart, and hopefully it'll become more apparent as we use R a little bit more. And so then we can pass that file name into read.csv. And of course we want to also save our data to something. So again, we'll use that arrow operator to put what we read from the CSV into my data. Now there's some other, really one other thing that I want to change here. Strings, and then it's auto-completing for me. So strings as factors where the A and the F are capitalized and everything is lowercase. So you'll notice, if you didn't already notice in Python, it's case sensitive, R is case sensitive, so you really want to pay attention to uppercase and lowercase. And then I'm going to put false in all caps. And for now, we'll get more into later what factors are, but for now just know that this is going to make your life a little bit easier, and some weird things can happen if you don't set it this way. Once you understand exactly what this is for, you can leave it as true. All right, and so I can also save this script. And so it's giving me the option to save in my project folder. And let's call this data import, and then .r. Whatever you call it, be sure to put .r at the end. And so now I see that over here, and a lot like I mentioned, the Python files are just plain text. You can open them in any text editor. Same with the R file. I could open this in Notepad if I wanted to. And Google was helpful for finding our help manual pages in Python. In R, they're already, every function you have in R, there's a help page installed on your computer already. So I put my cursor down here in the console, and if I type a question mark and then read.csv, and I just hit escape to get rid of the autocomplete because I typed the whole thing that I wanted, and then I hit enter, and now I have the help page for that, which sometimes these are useful. I mean, and this one is useful if you have the time to go through it and figure out what every single argument does and if that's useful to you or not. If you find that the help pages are a little too technical, then it's time to Google and see if someone's got a tutorial that's a little bit better. Okay, so to run my script, if I press the source button, it will run the whole thing, kind of like we did in Python, where we clicked that green arrow and it ran the whole script at once. But how people more commonly use R is they'll run it one line at a time, and that allows you to use it a little bit more interactively and kind of check things as you go without having to rerun the whole thing. So if I put my cursor up on read.csv, or sorry, on my CSV is russianmiscanthus.csv, and I press the run button, now I see that I have this variable showing up in my environment pane, a lot like I had the variables pane in Thonny. And I can do the same with this line of code, and now I have my data. with all of the data that I imported. And you'll see RStudio will kind of categorize these a little bit differently. It identifies certain types of objects as being data sets versus values, and we'll see some other categories a little bit later. So one more way that I can run a line of code besides pressing the run button, let's just put a simple command here, 1 + 1. So I can press the run button to run this, or I can press the control key and enter. And so I'm telling you that right now because that's probably what I'm going to do a lot of the time. So if you see me just sort of executing code without clicking anything, that's what I'm doing. I'm putting the cursor on what I want to execute and then hitting control enter. And you'll notice every time I do that, that command gets sent down to the console and then the output gets printed. So anyway, let's take a look at the data that we've imported. So one thing you can actually do is you can click on it right in here in the environment pane, and it's going to run this view command when you do that. You could also type that command in manually. And so this gives us a nice preview, or really we can view the whole thing, of our data that we just imported. Now I don't recommend doing this, say if you have like hundreds of columns especially, or a very large data set, because it's going to really slow things down. It'll take a while to load. But this, for a smallish data set like this, it gives us a good preview. We can notice that in the column names, a lot of special characters have been replaced with periods. That's so that we can use those as valid variable names, but I'll show you how to clean that up a bit if you want. And we can see that the header correctly imported as a header, and the data look about right. Another thing that I always do after importing any data set, or sometimes even when creating data in my script, is a command called str, which I believe is short for structure. And you can use that on any object or variable in R, and it will tell you some useful information about that. So I'm going to run control enter on that, and I get a printout with a bunch of information. So one thing to notice is that this is called a data frame. So this is different from any of the data structures that we were just looking at in Python. This is sort of R's default data structure for if you're having spreadsheet-like data. And the way it's different from an array is that it can contain a mix of numeric and text and other types of data. Every column has to be all of the same thing, but the columns can be different from each other. So we see each column name here after a $sign. And then we see a little abbreviation here that shows us what type of data is in that column. So for these two, it imported it as character. And then afterwards we see NUM for numeric. And there was one where there were no decimal numbers, so it decided to make that an integer rather than a regular number, which for your purposes right now, you can think of these as exactly the same thing. It's only when you start getting really advanced that you need to know the difference. Another reason why it's important to run this str command immediately after import is that it's so easy to make a typo in your spreadsheet, especially if you made it by hand, and maybe you typed a question mark where there was missing data, or there was a space after one number, or you put 2 points into one of your numbers instead of 1 decimal point. Any of those sorts of things are going to cause the whole column to get imported as text instead of an integer. And so if you find that that's happened, you see a CHR where you're expecting a number, then that means you need to go back and clean up the spreadsheet a bit. And so in one of my emergency R videos, I show some tips for looking for those sorts of values in Excel. So check that out if you're looking for more details on cleaning up your data. Okay, so let's pause the video and do a small exercise. So make a small spreadsheet like the one I suggested you make for the Python portion of the video, and try to have some columns that will import as text and some that will import as numeric, and save it as a CSV. and then try out running it with the read CSV command. So if you like, you can make a whole new script, or you can just add a few lines to this script to read the new file, since that would be a quick copy and paste. So pause the video, try that out, try importing both text and numbers. Okay, welcome back. So let me take the spreadsheet that I made for the earlier part of the video, and I'll just edit it a bit to put in a text column. Dog, yes. Dog, bird, just something kind of random like that. Let me also deliberately put in an error that I might make while typing a number. So say I accidentally put in 2 decimal places. So I'm going to save that, and it should just save as the same CSV file. I'll leave it open for the purpose of editing it later. So if you like, you can make a totally different script for reading that file. I'm just going to put it in the same script, and I'll call that data set something else. These names are kind of arbitrary, and they can be just about anything as long as they're just letters, numbers, periods, and underscores, no other characters. And so I'll copy and paste that. And in this case, I'm just going to put the name of the file right in here. It works either way, but I don't expect to use that file name again, so I'm just going to type it in directly. And I'm also going to put a line break there for readability, just because my screen is very small right here. This line break will be totally ignored by R. So, use them if it makes the code more readable. So I will run that, and it shows up here. I can preview it with view, and I might view that and think without looking too hard, oh, that looks just fine. Say this was I had a much bigger spreadsheet with hundreds of rows and just one mistake. But I can run str on it, and I can see, oh, this B column got imported as character. So that might not be quite what I wanted. So if I went back and say I found this mistake, maybe I looked at that tutorial video on how to find these mistakes, and saved it again. Now, without rerunning the whole script, I can put my cursor back up here and just rerun this line. And now I can see that it's fixed and it's a number. Okay, so let me clean up this script and add some comments. So the comment character is the hash symbol, just like it was in Python. And maybe I don't need this 1 + 1 anymore. And I can mark off this section here for what it was. So now let's look at extracting individual columns. Because in Python we had those all separated out, but right here we have my data still all as one object together. So my preferred method, there are several ways of indexing a data frame. But you'll remember we have this $sign when we looked at str. That's because the $sign is an operator that can get us a particular column of a data frame. So let's say I want to look at species, and I run that, and now it's just printing out that species column. And what these individual columns are there's something called vectors. Right, so a vector is analogous to those one-dimensional arrays that we had in Numpy. So it's one-dimensional data, and it all has to be the same type. And in R, even if you have just one value, it is technically a vector. So we have all sorts of commands for testing these things. So I can test, is this a vector? It's going to say that's true. But right here, when I made my CSV, that was just one value, right? But even that is considered a vector, which is a little bit different from Python, where a single value is a single value, and a list or an array is a list or an array, and those are two different things. But there are no real single values in R that aren't also vectors. And I can index these vectors very similarly to how I did it in R. So actually, let's get the accession number. Now in R, we start numbering from 1, not 0, which is maybe more intuitive for people who are new to coding, but it's counterintuitive to anyone else who's done programming because numbering from 0 is pretty common. But in R, we number starting at 1. So if I wanted to get, the data on the 15th one, and you'll notice I'm not bothering with print commands, because if I just type out the object itself or the subset of the object, it will print it by default. That's what it does with it. Right, so then I'm getting that information about that. I could also print out the whole 15th row. Similarly to Python, I can take something two-dimensional like that and do square brackets with a comma, where I'm specifying the rows first and then the columns. And in this case, if I want every column, I just leave it blank. Or if I wanted every row, I would leave that part blank. So I can put in numbers here for numbers of columns that I want as well, in addition to being able to get individual columns by naming them like this. Right, and so this, it wraps around a bit, but here we have the column headers and the values in that columns. So if I wanted to create a vector, you do that with something called, well, a command that's just a lowercase c. Right, and so the c is a function. I use parentheses, and then I can put in as many arguments that I want, and each argument is a value that's going to be in that vector. So if I print that out, I have those numbers, and the reason why I'm showing you that is that I did want to show you how to fix those column names, because they got changed to these kind of awkward long names. So there's a call names function that will return the names of those columns. But I can also do assignment into that. Right, so if I put the arrow here, then I'm putting something into those column names. So then I can create column names that I want. Like, I'd probably rather just call that first one accession. Maybe I want to spell out latitude and longitude. And like I said, underscores are okay. Maybe they look a little nicer than periods. So if I do that, now if I run call names again, I see my fixed ones, and I could actually preview my data again, and I see that they're fixed there. If I ran my str command again, which I have way up here, see, this is the danger. Even I'm doing it. You start running your script out of order. And I see that they've been fixed down here. So then after that, You know, if I wanted to run this, I would change how those were named, because it might complain if it's something that it doesn't recognize. Oh, I think that this one, yeah, so that works because it's short, but it's an abbreviated version of one of these, and it, you know, this lat doesn't match anything else besides latitude, so it still works. I can also do arithmetic on entire columns, and in fact I might want to save that to a new column rather than to a new variable. So let's say again that I want to have stem height in centimeters. So right, stem height, this is how I would extract the existing variable. But if I wanted to make a new one, I just put in a new name of one that doesn't exist yet. And I put the arrow there to put something into that name. So I can take my existing one, stem height, multiply by 100. And now if I looked at that data set, I have my stem height in centimeters that's been added to the data set. And that's nice because it's still sort of in the spreadsheet format, and so it's still very easily cross-referenced with all the other information. Right, and so we have very similar arithmetic. So plus for the plus sign, minus for subtraction. We have multiplication. We have division. And I believe the two asterisks still work for raising something to some other power. In R, you can also use that up-facing caret symbol to do that. So, similar to the other exercise, how about you add a column to this data frame that contains the elevation in feet? And then practice your indexing by getting the third item in that vector. So pause the video for a few minutes and try that out. Okay, welcome back. So how I would do that. And let me remind myself of what that was, because it's probably written in this other script. 3.28 was our conversion factor. So I can run that as well. If I do an STR now, I see I have elevation in feet in addition to the original elevation, and I could also look at it over here. And if I wanted to extract the third item from this new column that I made, I would use indexing like before, and the third item is item number 3. So if I run that, that gets my 167.28. All right, so that is that for this video. If you follow along with the next one, we're going to get more into indexing. For example, how we're extracting individual values and individual columns and that sort of thing, as well as something related in Python called slicing, which is if you want to get a bunch of values or a bunch of rows and columns at once. So stay tuned, come back next time.